Now that we know about slope y-intercept form of an equation, we're going to take that and we're going to extend it and we're going to work with something that's called standard form. So let's start by reviewing slope y-intercept form of the equation. So that's the one that looks like this that I just highlighted, y equals mx plus b. So part one, though, says to graph this equation here, and so we know that this number is the slope, in other words 4/5, and we know that this number is the y-intercept, that's the -3. And we also know that if we start with the y-intercept, let's just assume that this grid on the right has got a scale of 1, going up by 1 for each block. That means the y-intercept is going to be down here at -3 on the y-axis, just counting down from the origin. That would make that dot at -3. And then a slope of 4/5 means that I'm going to count up 1, 2, 3, 4, 4, and then go 5 to the right, 1, 2, 3, 4, 5 to the right, and put my next dot, right? So that's how we do it. We use count that way. And if we have enough room, we could do more dots. These ones are pretty spread out, and I can get a pretty good idea of what the graph's going to look like. Let's see. It's going to go something like this. So again, I'm trying to fill out the grid as much as possible. So I'm not just doing short little lines for my graphs. I'm filling the grid from side to side as much as possible. And there's my graph. It doesn't take long to do it, right? So that's the beauty of slope y-intercept form. I can graph things really quickly. Equations can also be written in what's known as standard form. Let's choose a different color to highlight that. So standard form looks like this. ax plus by plus c equals 0. You'll notice that what I've just highlighted, ax plus by plus c, it's still got an x and a y in it. It's got these other things in there that are a, b, and c. But a, b, and c are just going to be numbers when you see a real equation. They're like the m and the b in slope y-intercept form. You never see m or b in the actual slope y-intercept form equation. You see an actual number in for slope, and you see an actual number in for b, for y-intercept. Likewise, you're going to see actual numbers in for capital A, for capital B, and for capital C in this form of the equation. So really it's just letting you know the format that it looks like. Now there's a couple rules that go along with standard form, and we should get those out of the way right away. So two rules are, obviously everything goes on the left side with just it equals 0 on the right. Now that's hopefully obvious, so I won't state that. I won't write that down as a rule, but I hope you can see that. But the actual rules that you do need to be aware of is that you're not allowed to have any fractions. So no fractions in standard form. And if there is a fraction in an equation and you want to put it in standard form, we have ways of dealing with that. But in order to be considered standard form, there have to be no fractions. So a, b, and c have to be integer numbers, positive or negative whole numbers. And the other rule is that the first number, which is a, as you can see, that's the very first thing in standard form. It goes ax. So a has to be positive. And if a is not positive, again, we can fix that. So we can change things to put them in standard form. We can fix problems. So if we want to do this part here next, where it says keep the equation balanced, convert the equation into standard form, that's what we're going to do now. So we're going to take this equation and change it into standard form. So we do it by treating it like an equation, because it's a relation, but it's also an equation. And so we want to rearrange the equation. So the first thing I want to do, let's start by rewriting the equation. Y equals 4/5 x minus 3. Now I want to bring everything to the left-hand side, leaving 0 on the right. So if I bring the 4/5 x over, it becomes a negative 4/5 x, right? Because I'm subtracting 4/5 x from each side. And I'm putting that first because the x's come first. And then I got my y term, and there's already a y there. I don't need to change anything. This y right here, I just rewrote it again, but I need to put a plus sign in front of it now because it's part of an expression. But it was always positive. It's just that I didn't need to write the plus sign in front of it in slope y-intercept form. And then I'm going to bring the negative 3 over, and that becomes a plus 3. And since I brought everything over from the right, there's nothing left on the right-hand side, but I can't leave it like that. The way I represent nothing is by writing 0 down. So that's the first step in putting it in standard form. But you can see that we're breaking actually both of the rules that I just stated. First of all, there is a fraction involved, and second of all, the a value is not positive. I could deal with both of those at the same time, but to make it a bit easier to follow, I'll do one at a time. So let's deal with the no fractions part first of all. The way I deal with it is I remember that I can do anything to an equation as long as I do the same thing to both sides of it. So in this case, if I want to get rid of the fraction, I can get rid of this fraction right here if I multiply it by 5, right? If I multiply it by 5, the denominator will cancel with the 5 multiplying by 5, and I'm just left with negative 4x. But I can't do it just to that one part. So I have to multiply everything by 5. If I do every single term by the same number, the equation stays balanced. So I'll put brackets around this to show I'm going to do 5 times this. And again, the reason for that is so those 5's will cancel out. I'll do 5 times this. I'll do 5 times the 3. And I'll do 5 times the 0. And then just see what I get. Well, what I get is negative 4x plus 5y plus 15 equals 0, because 5 times 0 is still 0. So I've dealt with the I've dealt with the fraction. So it's still equivalent, right? The relation is still the same, and it's going to look exactly the same. And now I have to deal with the a being positive. And so again, I can't just do something. I can't just drop that negative sign because I want to. So I want this to be a positive 4x. And so that's fine. I can make this a positive 4x, but you have to think mathematically, how do I go from negative 4x to positive 4x mathematically? It's not just forgetting to write down the negative sign. Mathematically, what it is I am going to multiply that term by negative 1. Okay? So really, this is what I'm doing. I'm multiplying by negative 1. And then I have to do the same thing to every term. So I'm going to multiply this term by negative 1. And I'm going to multiply this term by negative 1. And I'm going to multiply this term by negative 1. And what I'll get is it's just going to change the signs. Negative 1 times positive 5y becomes negative 5y. Negative 1 times positive 15 becomes negative 15. Negative 1 times 0 is still 0. So now it's in standard form. A value is positive. There's no fractions. Everything's on the left-hand side. It's in the right order. This is standard form. I can check to see if I did this properly just by going to Desmos, which is right here. And if I go y equals 4/5 x minus 3, that was my original equation. Okay, let's put it in blue just for fun. And now I've got my standard form equation, which you remember was 4x minus 5y minus 15 equals 0. I can type that in Desmos as well. 4x minus 5y minus 15 equals 0. Let's change the color here of this one. Make that one red. What you'll notice is I've got the exact same line. In fact, you can tell what I'm going to do is I'm going to toggle it on and off. So I just turned off the second line. That you notice that on the left there, that red circle, see how the red circle is filling in and disappearing? That's because I'm just toggling it on and off. So what you can see if I take the red line away, the blue one's still underneath it. So the red one is lying right on top of the blue one. It means it's the exact same relationship. So all we've done is change the form. The one that I've got in blue is in slope y intercept form. The one that's in red is in standard form. They're the same relationship, just rearranged. And so that's what we're sort of dealing with today. Just how do we rewrite the equations from one form to another? So how can a line be graphed when it is given in standard form? I'd say the easiest way is rewrite it in slope y-intercept form. Okay, so let's try that. So we just got a few examples that do exactly this. The first one's a multiple choice question. It says, which of the following equations is equivalent to 3x minus 5y equals 45? You'll notice that there's 4 answers, A, B, C, and D, and they're all in slope y-intercept form. So what I've highlighted in yellow actually isn't in standard form. It's not in slope y-intercept form either. It's just sort of this in-between form that doesn't have a name. But we can certainly tell, or we can certainly answer this question by changing this from this form into slope y-intercept form. So to do that, we want to have, we want to have it in this form. And in this form, the y is by itself. So we're going to isolate y. So we're going to sort of do the opposite of what I just did. We're going to rearrange it into slope y-intercept form. And you've done some of this already. So rearranging, I'm going to leave the y term where it is. Negative 5y stays there. Bring the 3x to the other side. Put it first. Slip it in front of that plus 45. And then I'll divide everything by negative 5. Cancels out there. I end up with y equals, these two negative signs cancel out, so 3/5 x. The negative and the positive here become a negative overall, so that becomes negative, and then 45 divided by 5 is 9. That matches up with part A. That's my correct answer. And that's how you show it. Which of the following is the equation of the line 6x minus 2y minus 12 equals 0? So this one is in standard form. I'm starting with this. I want to put it into slope y-intercept form. Let's do the exact same thing. We're going to rearrange it into that form by, again, isolating y. So I'll leave the y term, negative 2y on the left. I'll bring the other terms over, so 6x becomes negative 6x. Negative 12 becomes positive 12 when I swap sides. Divide by negative 2. They cancel out there. Y equals, and then I get positive 3x, and I get negative 6. Again, paying close attention to the signs, right? There's signs here and these signs here that I'm combining. Let's use a different highlighter for these two. So we're simplifying signs there. That's a plus there. I don't need to write it in, but I will just so to make it clear. And what does that one match up with? Well, that matches up with B part. So if you're hopefully getting good at rearranging equations, then this is a quick question to do. And in fact, this example here are just 2 more of the exact same thing. So we can go through these quickly. Let's do that. Negative 3y equals negative 2x minus 12. See where that came from? Just rearranging. Divide by negative 3, divide by negative 3. Do that 3 times. Cancels out. Y equals positive 2/3 x plus 4. Again, just simplifying signs. What about this one here? This question says, convert the following from standard form, but I would say what I've just highlighted is not in standard form. Can you tell me why it's not in standard form? The reason it's not in standard form is because it's got this minus sign out front. So I would disagree with saying that it's in standard form. It doesn't change what we do, though. We can still work with it. 7y, leave the y term where it is. bring the 5x over, change the sign, bring the 14 over, change its sign, divide by 7, oops, I was doing it a bit different before, so I'll carry on. Divide by 7 like this, cancels out, y equals 5/7 x plus 2. There's my answer for that one. Fast. Convert the following from y equals mx plus b to standard form. Now we're just going the other way again. So going from y equals mx plus b to standard. So we put them in order. We want it to look like this. ax plus by plus c equals 0. Step 1, bring everything over, put them in the correct order. So I'm going to put the x term first, changing the sign, plus y minus 5 equals 0. Do you understand why I didn't change the sign of the y, but I did of the x and the constant term? It's because 6x and 5 swapped over to the left side of the equation. It crossed the equal sign. Y didn't go anywhere. That's why it doesn't change signs. Now, I don't have any fractions here, so that's good. All I have to do is get rid of the negative sign that's in front of the 6x. So I'm going to multiply everything by -1. But I don't have to write out times -1 for all these things. All I need to know is that if I multiply by -1, the sign changes. So -6x times -1 becomes positive 6x. Y times -1 becomes negative y. -5 times -1 becomes positive 5. 0 times -1 is 0, because 0 is neither positive nor negative. So all these signs just became the opposite. This became positive. This became negative. This became positive. Okay? That's all you got to pay attention to. Let's do it again. 3x plus y plus 4 equals 0. Understand where the signs are coming from? If not, backtrack and listen to my explanation from the previous part, number 1. Does it have fractions? No. Is a positive? Yes. This is in standard form. This one's done. The last one. -1/2 x plus y plus 3 equals 0. Now we've got fractions and negative a value. I could do both things at once. I need to multiply each term by 2, right? Because that's what's going to get rid of the fraction here. I need to multiply that by 2 to get rid of the fraction, which means I have to multiply everything by 2. But I also have to deal with this negative sign here, which means I'm going to multiply by -1. Well, I could just multiply everything by -2 and deal with it all at once, right? So if I multiply the first term by -2, I get positive 1x. And the next one by -2 gives me -2y. -6 equals 0. So I just talked it out, and I talked it out quickly, but I'm hoping you're getting it. If not, that's the beauty of a recording. Rewind a bit and listen to what I said before, because I'm just getting rid of the things that I need to get rid of. I'm getting rid of the fraction, and I'm getting rid of the negative a value by multiplying by the appropriate number.